Thanks very much, Alex. I'm going to talk about my talk's basically divided into two. One is just briefly describe the ways in which the Iran deal goes beyond the verification arrangements of the standard IAEA safeguards arrangements, and then second, talk about what happens after the deal expires, which has been one of the main criticisms, and just some thoughts about what we might do to make the proliferation, well, to deal with the danger of proliferation of national enrichment plants like Iran's. So briefly, on the evolution of IAEA safeguards. The basic safeguards agreement that came with the NPT focuses on verifying countries' declarations of their nuclear materials. That was found inadequate when it was discovered that across the street Iraq was doing other things. And so the additional protocol was developed, which requires countries to declare all their nuclear-related activities, including activities which don't involve nuclear materials, such as centrifuge production. With regard to the Iran deal, Iran has agreed to provisional application of the additional protocol, and with 8 years from now to get the Majlis, their parliament, to ratify it. Now, there are additional elements of the deal, nothing fancy technically, but I think important. And they're basically motivated by two motivations. One is to detect quickly any breakout of the existing known declared facilities, especially Natanz. That is a breakout, instead of producing the low enriched uranium enriched to less than 3.67%, which is the limit in the agreement, to all of a sudden to rearrange the cascades to produce highly enriched uranium for weapons. And the second is to make it as difficult as possible to do clandestine enrichment or reprocessing. So first, at Natanz, they will have continuous measurements in the headers of the cascades of the enrichment. So, and they will remotely monitor those measurements, and Iran is committed to this for 15 years. And then, secondly, there will be a minimal, if any, production of centrifuges. But if, to the extent there is, the components, the critical components, which are the rotors and the bellows, which connect rotors which have multiple sections, will be monitored, and the equipment to produce them will also be monitored. That's flow forming machines, filament winding machines. For these, the ones shown in the picture here are carbon fiber reinforced, and mandrels. Additionally, it's important that the agreement makes Iran's supply chains for both materials and technologies more transparent. It goes back actually to uranium mines and to milling of uranium and conversion to uranium hexafluoride, which is the form which is used in gas centrifuges, and also purchases of foreign technology materials all have to go through, be cleared through a committee, a joint procurement working group for 25 years. And then finally, there's this very a lot of focus on this way of forcing resolution of disagreements about access, where when the IAEA asked for access, within 24 days of an impasse arising, there has to be a resolution, or the sanctions can be snapped back. And this is to deal with situations like the one with Parchin, where the IAEA had been for several years seeking access, and the IAEA and Iran was stalling. Now, on the plutonium side, Iran has agreed to no reprocessing facilities or reprocessing, and for at least 15 years they said they're not interested in reprocessing. No additional heavy water reactors, which are of concern because they're fueled by natural uranium, and which maximizes the production of plutonium in the fuel. All the spent fuel from Iranian reactors are to be shipped out of country. And in the case of the reactor, the heavy water research reactor, which was of special concern within 1 year. I show on the bottom an infrared image that I published in an article in Scientific American 30 years ago, advocating a fissile material cutoff treaty. And you can see this is actually the hot water outflow from the U.S. plutonium production reactors at Savannah River. They're much more powerful than the Iraq reactor. They were about 2,000 megawatts versus about 40 megawatts. But it just demonstrates that people don't worry too much about hiding reactors. There's also another contentious area of the agreement is the so-called possible military dimensions of Iran's activities in the past, especially before 2003, when its program became public, when there are many indicators that Iran was, in fact, exploring nuclear weapons design. This is supposed to be resolved very quickly now. The IAEA has been trying to resolve it since 2003. As part of the deal, the IAEA and Iran agreed on a roadmap to clarify these issues. In the middle of August, Iran provided the IAEA with its explanations of the issues that the IAEA had listed, and in middle of December, the Director General of the IAEA is supposed to provide his judgment on the resolution of these issues. I think that this is just too fast a schedule, really, to settle these issues. I think but it was forced by the exigencies of the negotiations. But some comfort, I think, can be obtained by the fact that in the U.S. estimate, the U.S. was seeking to get a minimum of 12 months warning of any Iranian breakout. That in that estimate, the assumption is that as soon as it would take zero time for Iran to make a nuclear weapon from the time it obtained enough material for a weapon. Now, just to briefly on understanding this 1 year breakout time, in the case of enrichment, this figure shows the the number of SWUs required to get so what the IAEA calls a significant quantity of HEU, that is HEU containing 25 kilograms of U-235, as a function of the enrichment of the feed. And I think that this figure, if you start on the upper left there, if you have just natural uranium, then it would take about 5,000 SWUs. And the one centrifuge that Iran will be having working in quantity for the next 10 years is the IR-1, which conveniently produces about one separative work unit a year. So it's about 5,000 IR-1s. But of course, if you feed in partially enriched uranium, the number of SWUs required to produce a significant quantity goes down. About 1,800 for the 3.5% enriched uranium that Iran has been producing, and down to 500 if you have 20%, which Iran also was producing. So a major goal, and basically these arrows show trace the path of escalation of this confrontation, where Iran did move down this curve to produce 20% enriched uranium for its Tehran research reactor, but it could, of course, been fed back in, which was to make weapons-grade uranium. And now we have the arrows going the other way, where all of that 20% enriched uranium is to be has been converted from uranium hexafluoride to uranium oxide, and much of it has been fabricated into fuel. No more is being made, and Iran is in the course of reducing its stockpile of 3.5% enriched uranium to less, about a quarter of the quantity required to actually produce a significant quantity. So that basically the agreement moves Iran up to the upper left, back up to the upper left corner as far as possible. Now, what happens after 10 years? The problem of national enrichment plants has been recognized since 1946. Since the first analysis of proliferation in the Atchison-Lilienthal report, which was actually written to a large extent by J. Robert Oppenheimer. And it described uranium enrichment and national uranium enrichment and reprocessing facilities. Reprocessing facilities separate plutonium as dangerous technologies, and argued that those should be under international control. Well, that didn't happen because of the Cold War, and so proliferation happened, and as they've Oppenheimer and Atchison-Lilienthal feared, a number of programs started, which national enrichment and reprocessing programs started, some of which were ambiguous initially, what the intention was, but many of which produced nuclear weapons. Today we have 3 non-weapon states, Brazil, Iran, and Japan, with national enrichment plants, which do provide them which make them threshold nuclear weapon states. So this is a real problem. A better alternative would be to go at least part way back to what the Atchison-Lilienthal plan advocated, which was to put enrichment plants under at least multinational control. And it's interesting here that in fact there is a multinational, Urenco, which in fact has about 1/3 of the global enrichment capacity. you see that I mentioned Japan, Brazil, and Iran, as non-weapon states with enrichment outside of Urenco. Of course, there are two non-weapon states inside Urenco, Germany and the UK, and the Netherlands. And you see that they have very small part of the global enrichment capacity, but in fact, they have enough to make significant quantities of HEU. I note that the U.S. does not have. I mean, the U.S. used to have a enrichment capacity comparable to what Russia has now, but it was gaseous diffusion. It became non-competitive when centrifuges took over, and has been retired. The U.S. Privatized its enrichment complex in the form of the U.S. Enrichment Corporation, which then went bankrupt. So we don't have a national enrichment facility. We do have one commercial enrichment facility operating in the U.S. It's owned by Urenco. So in 1977, the U.S. During the Carter administration, we decided to give up reprocessing. That was after India used an Atoms for Peace plutonium separation program to make a nuclear explosive, and we then looked at whether in fact reprocessing was necessary for the future nuclear power, and concluded that it wasn't. Now we could say that with regard to national enrichment plants, as we've said with reprocessing, we don't do it. You don't need to either, and that has been very effective in the reprocessing area. So in conclusion, there are a number of elements in the Iran deal which if applied generally could make enrichment less dangerous. The centralizing import and manufacture of centrifuge rotors and key materials used to make them, centralizing production and stocks of UF6. There are the multinationalization approach, and which is something that a group of us has been discussing with Iranian Foreign Minister Zarif. Could provide some protection against breakout, and exactly what we're trying to figure out what we mean by multinationalization in this case, and my own thoughts at the moment are multinationalizing operating crews and putting all the supply chains under multinational oversight as well. And then with regard to moving away from national enrichment plants and starting with new national plants, new plants that would have to be compared with reliance on existing plants or multinational alternatives, and then really confronting the issue of multinationalizing. I mean, since the non-weapon states will not accept a two-tier world indefinitely, talking about multinationalizing or shutting down existing national plants. So that's it. Thank you.
And I think there are unique opportunities for synergisms in this area. The research area 1, the policy research thrust, really emphasizes, of course, the treatment